Okay, we've got here the tuning mechanism for radio. It's an LCR circuit. Station is tuned when the circuit resonates at the frequency of the station. Calculate the frequency of the station that would be picked up when the capacitor is set to 200 picofarads. So let's have a look at our equations. We've got our inductive reactance and capacitive reactance, and at resonance these are equal. XC equals XL, which will lead us to, if this equals this, then we end up with this formula here for resonant frequency. And if we want to make inductance or capacitance the subject of the formula, it's sometimes easier just to use this form of the formula, where if we square both sides we have resonant frequency squared equals this, and we can rearrange that easily to make inductance of the inductor the subject of the formula, or capacitance of the capacitor. So let's then come back to where we were, calculate the frequency of the station at resonance. So let's try our equation here. The resonant frequency equals 1 divided by 2 pi square root LC equals 1 divided by 2 times pi times square root inductance is 15 millihenry times capacitance 200 picofarad. Now remember, milli 10 to the negative 3, micro 10 to the negative 6, nano 10 to the negative 9, and pico 10 to the negative 12. So if we substitute those in, we get the frequencies equal to 91,888, but we've only got two significant figures, so we've got to call that 92,000 hertz. And in keeping with radio station frequencies, we're going to call that 92 kilohertz. Now calculate the capacitance of the capacitor, a variable capacitor, if our radio is tuned to hierarchy FM, 99 kilohertz. Let's go and check our formulae again. Our formula here for capacitance is going to be this one here, the rearrangement of that formula. So let's try that then. Capacitance equals 1 divided by 4 pi squared F squared times L. That equals 1 over 4 times pi squared times frequency, 99 times 10 cubed, 99 hertz, kilohertz squared, times 15 millihenries, which is 15 times 10 to the negative 3, and that one we will end up with a capacitance of 1722 times 10 to the negative 10, which we've only got two significant figures, so we're going to do 1.7 times 10 to the negative 10, or we can make that, if we want, 1.7 times 10 to the negative 10. Hey, I've just written that twice. Farad. That's the answer. Okay. Good luck tuning in on that radio station. See you later.